Okay, the bit of information that we're going to get into this time is still part of chapter 28, although the information itself is out of a totally different section in the book. So when you get to the end of this and you have to do assignments, I will tell you the page numbers, and I'll make sure you have the correct page numbers in your book, because again, it's out of a totally different section. So what we're going to talk about then is the energy that comes from the sun. How does it heat up the earth? How does it affect the earth? Well, there are basically three things that happen to the energy Earth gets from the sun. About 30% of all the total energy is reflected right back into space. It never even reaches the ground. It basically bounces off some of the upper atmosphere, some of the upper clouds, and again, it doesn't even reach the surface. About 20% is absorbed by the upper atmosphere, the gases that are higher in the atmosphere. So that means that only about half, 50%, of all the sun's total energy is actually absorbed by land and water surfaces. It's this 20% that, this 50% that we're interested in, because this is the part that heats up the earth. So how? How exactly does energy get across from the sun to the earth's surface and heat it up? How is it transferred? Transfer means across. Well, there's three ways that it does it. Radiation is the first way. Radiation is the transfer of energy by, big word here, electromagnetic waves. Now, we haven't got to astronomy yet, but electromagnetic waves are all the different forms of radiation that come from all stars, not just our sun. So things like gamma rays, X-rays, ultraviolet rays, infrared rays, radio waves. Those are all the different forms of radiation. Scientists together call that the electromagnetic spectrum. What does this mean to us? Well, we feel radiation in the form of heat. So think about you at the beach, building your sandcastles, the sun beating down on you, and you get sunburn. That's a great example of radiation. Well, radiation that's given off by Earth's surface contributes very little radiation back to space. In other words, once it reaches the surface, it's basically here. It stays here. It gets trapped here, and it doesn't really leave at this point, doesn't reflect back into space. And like I said before, this is part of the previous set of notes, there's a very delicate balance between what's absorbed and what's given off. Alright, so besides radiation, what's another form of energy transfer? Well, the second form is called conduction. Conduction is the transfer of energy that occurs when molecules bump into one another. So in class, I always have kids explain to me step by step how you would make soup. So usually it goes something like this, if they tell me correctly. I open a can of soup, I dump it in this pot, and I heat it up. Okay, well, it's more than just that. It's not like you dump the can of soup right on the burner on the stove. The pot sits on the stove. So when you turn on the stove, that energy is transferred from the burner on the stove to the pot itself. It heats up the pot. The soup that's on the inside of the pot then, the soup is touching the pot. So the soup is in physical contact with the pot. So the molecules are bumping into one another from the pot to the soup. Well, that's the way you got to think of the atmosphere. Objects on the Earth's surface transfer energy directly to the atmosphere. In other words, the atmosphere extends right down to the surface. So as the sun's energy heats up the surface and warms the Earth's surface, that energy is eventually transferred to the atmosphere itself. It's always transferred from faster moving molecules to slower moving molecules. Two of them move at the same rate. And the third method, the third system, is called convection. Convection is the transfer of energy that occurs due to density differences in the atmosphere. So when air is warmed, air molecules move apart. So in other words, as the molecules start zipping around quicker, they spread out, they take more volume. Well, the bigger the volume, that's lesser density, less dense something is. That's why warm air, warm water always rises up. Lower density means also that there's less air pressure. Well, if air pressure is lower, that means the barometer is dropping them. There's fewer molecules pressing on each other. Cold air temperature and pressure are just the opposite. Now, your notes, I only included it with 6 slides. I didn't go to 7 slides, so you didn't have one slide hanging out there. But an important term or concept that you will see possibly on quizzes and tests are convection currents. Convection currents are always the circular movements of air due to the pushing of cool air masses on warm. And we talked about convection currents with the geology units. Convection happens in the mantle. It's what makes the tectonic plates move around. Convection currents happen in the world's oceans. It's what makes water rise and fall in the world's oceans as well. So convection currents is a very important concept. Alright, so the pages in the book that you will find information about radiation, conduction, convection that'll help you answer the different assignments is page 144 to 147 in your book. So that's where you'll have to read and find the information that kind of goes along with the assignments in this section.